There is one other caller on the call.
Hello.
Hello.
Great. Hello. 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 Okay. Hi guys, can you hear me? Type in the chat message so that I can respond. Hi all, can you see the chat log? Hello. Hi Shashank, what's the problem? Could you quickly type? I can help. So I have actually muted all the people, and so some more people are trying to join. I think it will be wise to wait for some time. Great, great. Hi Kalyan, hi Hari, hi Shashank. Can you hear me? Okay, great, 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 great. So the way these sessions happen is that all the attendees are muted except for myself. Okay, and except for the presenter, and everybody communicates with him over the. Okay, so what he's suggesting to basically change the microphone. Just give me a second. Just give me a second. Let me see. Use. Okay, okay. And volume. How do you increase the volume of? Okay, I don't see any option to increase the volume. Hi Chintamani, welcome to the session. So Hari, still louder is required. Can you hear me clearly? Kalyan is able to hear clearly, and okay, I'll have to minimize some of the things. So 7 persons have joined. Kalyan, Sukhavat, Hari, Chintamani, and others are also joining. Okay. Increase the volume, Hari. It seems that your machine's volume is a little lower. Okay. So these teething issues should be over only by today itself. So I don't think that these problems would be there tomorrow. Great. Other people are actually trying to join. I'm waiting for some more people to come in. And there'll be at least 4 more people. 5 more people actually. Just give me a second. Hello? Hello. Yeah. Hello, everybody. Welcome to the class. And actually, one more person is trying to join, so give us some time and then we will start immediately. Thank you. In the meantime, please introduce yourself and about a little bit of about your background and where are you located and where are you based out of. So it will be great if you guys introduce yourself. Okay. Hi, Kalyan. Welcome, Kalyan. Kalyan has got 8 years of experience in data warehousing area. And here is Bhagwat. Bhagwat is from Atlanta, GA, and he works for satellite image processing company here. Hello, everybody. He's Gaurav Gupta. Welcome, Gaurav. He's from Pitney Bowes. Okay. It will definitely boost your career, Kalyan. I'm very sure. I'm very sure. Great. Hello, Arun. So Arun is working into ETL domain. ETL is extract, transform, and load. These are various kinds of tools which help you transform and load the data into the database. Hi, Hari. Hari has 7 years plus experience in software development and is currently working in Bookcore Advertising Private Limited. Great. So I will have to. Okay, great. Okay, Vivek has also joined. Okay, great. So everybody has joined now. Okay. So everybody has joined. And hi, Chintamani. Chintamani is from Mumbai, 22 years in IT. Great, great. And he is into Unix and RDBMS and also a Unix shell script trainer for past 12 years. Would like to change my track to big data in near future. Great, great, great. Awesome. So we have got a great class today, and we have Hari, Arun, Kalyan, Gaurav, Bhagwat, Anto, and Shashank is there. Shashank, can you hear us? It will be great. It'll be great if you introduce yourself once. Shashank and Sukhavat. Uh, it'll be great if you also introduce yourself. If you're not able to hear clearly, let me know so that we can help you fix it. Okay, great, great. Shashank, please introduce yourself. And great. Hi, so time to start. Shashank is working with the SCDL Pune as Senior Oracle DBA. Great, great, great. And okay, so it's only me who is left for the introduction. Anyway, you must have, you know, gone through the my introduction, but anyway, I'll go again. And at the end of every slide, I'm going to look at the questions. So for every question, please ask in the comment window. So today's session is going to be on a faster track as compared to the previous one. And today we are going to go for the environment overview and MapReduce introduction. Okay. So I'm actually, fine tuning the course as we go based on the set of audience also. Okay. As well as based on the audience feedback. So do not worry about if you see the different title little bit. Okay. So welcome to No Big Data. No Big Data is an instructor-led online big data training organization. We specialize in big data trainings as well as consulting. So, and all of our instructors and people who are working with us, they are into big data domain mainly. Okay. So for Hadoop and MongoDB, I am the instructor right now. And for data sciences, there are other people who are taking it who are senior than me. So what is so special about no big data? Can you see my screen? Can you see the screen clearly? Okay, great. Okay, so I'm going to minimize a lot of windows, and yes, great. So what is so special about no big data? We basically, the whole premise of an instructor-led training is answering questions. Otherwise, people can watch the recorded videos. Okay, so we focus a lot on answering questions. Okay. Second is lifetime access to the content. This video is going to be recorded and is going to be uploaded as well, which you can watch at the later point of time. And we provide the most unique thing about No Big Data is that we provide a playground for all the people so that you can log in and all of these things. Probably all of you are aware because it's a second class, so I don't need to go through it. And you have already attended my first sessions. And this is my background. Probably, I think almost everybody is aware about this. So let's just get to the business. Okay. So today we are going to, we have gone through a session called Understanding Big Data and Hadoop Architecture. Basic Hadoop architecture we have gone through where we talked about HDFS architecture and uh, and your basically task managers. Now, today's session is about our environment overview and then MapReduce basics. Okay, basics are going to be little on the faster track. You will have to stay tuned. Okay, are dedicating 1.5 class completely to MapReduce framework. Okay, and if that doesn't suffice, and if I notice that most of us are not able to still handle MapReduce problems, I will further extend it to another classes. Okay, so do not worry about it. As we go along, if I see that people are not able to solve MapReduce problems, then I will try to explain it more, and maybe one-to-one sessions I will keep. Okay. So because MapReduce is the heart of any big data processing as today, although there are newer technologies are coming up. So as of today, MapReduce is the paradigm which defines big data processing mostly. That is why I'm going to take a little bit more time. Okay. So okay, a bit of recap is here. So, do you guys have a question about architecture? We discussed in the HDFS architecture last time in the session 1 that there is a name node and there is a data node. Name node's duty is to do the bookkeeping, and data node's duty is to provide storage, provide read and writes to the end client. Okay. And name node, what does it keep I mean, what bookkeeping is it doing? It does the bookkeeping like when you give it a file and you say, I need a 2 replica backup of this file, name node is going to split your file into small pieces and replicate those pieces those many times based on how much replication do you want. Also, name node keeps track of the data nodes in case any of the data node goes down, causing the replication factor of each file to go below what was required. Those pieces which have gone missing, or those pieces which were there on this data node which was just lost, will be replicated onto another machines to maintain the same replication level. Also, the replication, uh, if there are 2 pieces of a file, they will never go into the same hard disk ever. Okay. If they go into the same hard disk, it is not considered replication. Okay. And so, but name node, to avoid a name node from becoming the bottleneck, name node does not provide any reads or writes to the end user. The reads and writes happen directly on the data nodes. This also assists in couple of more ideas, such as the speed at which you are reading from the file system. If there are multiple customers for the same file at a different points of times, they can access the file from different machines because chunks are distributed all across. So this is generally the architecture of HDFS as we discussed last time. So I want to answer your questions now. Sure. Chintamani's question is that Chintamani has sent a question. Chintamani, you can send the question to all the people, no problems. Okay. So his question is, could you give us some commands to be given on the command line? Just a second. Okay. Command line to find out details about name node etc. Do not worry, I'll be giving. Okay. So thank you, Arun, for the question. He says that do we have a backup for name node? Yes. So in the newer architectures, there is a something first, there is a something called a secondary name node. What it does is it keeps the backup of the metadata, and when name node goes down, it forms the metadata from the history, and then it is turned on. Okay, but say the name node, the way we design name node is we we keep a basically we keep the zero load onto name node first. Second, we keep a secondary name node and also keep a backup of the name node. Okay, backup of the name node is keeps itself updated from the metadata of name node all the time, and the moment name node goes down, it automatically switches to the other one. Okay, so it is that way the name node is handled. Okay, great. Now, so do we have any questions right now? Please feel free to ask the questions. So if anybody is having any doubts right now, because I'm going to move ahead with the respect to other topics, it will be great if you cover up the SDFS architecture and the other architecture right away. Okay. Yes, Chintamani, all these PPTs will be available to you. Okay. They are anyway. If have you logged in to your dashboard? No big data, and then my courses. Under that, at the end of every class, these PPTs are going to be available there, along with all the instructions, plus the recorded video. As soon as we are able to upload the video, we put it there. Okay, great. Moving on. So my idea is that even if we have to extend a bit, meaning in case we are not able to cover in 10 sessions, I am okay to extend one more session, but let's not rush into it. Okay, that is why I'm okay. Let me, is my voice breaking for others also? Okay, okay, so maybe some intermittent network issues there which might cause the voice to break temporarily. You can close the session and open again in case you are not able to hear anything. Okay, and this video is getting recorded. Okay, so it will be available to you at the end of session. Fine. Now, okay. Now, so since everybody is clear about STFS architecture, so this is one diagram. For simplicity reasons, we have kept this one. Okay. In case this was the Apache Hadoop 1.0 diagram, to for the sake of simplicity, I have kept it. It gives a very clear idea what exactly happens there. Okay. Now, there is something called job tracker. There is something called job tracker to which you assign, give out your jobs, and based on the your and this job tracker divides this work to the task trackers. So you give your MapReduce logic to task job tracker, and job tracker is going to take your logic and give it to each individual task trackers. And the task trackers are selected based on which file you have selected as input. So you tell job tracker, this is my map, this is my this is the logic for my map, this is the logic for my reducer, and these are the files I'm going to read. So this information you hand over to job tracker after you have put it on the HDFS, all of this this definition of your request onto the HDFS, and then you tell job tracker ki, hey, this is what I want to get executed. And job tracker will send your job to the nodes which have the pieces of the file you are demanding for. And then that map and reduce is going to get executed on each individual task trackers. Okay. Okay. And map and reduce is going to be sent to each individual task trackers, and task trackers are going to work on it and then respond back to the job tracker that I am done with the job. In case the task tracker doesn't respond, job tracker start pinging each task tracker and asking, what's up with you? Why are you taking so much time? In case the ping response is not there from task tracker, it would assume that the task tracker is dead. It will assume that the task tracker is dead, and then will schedule your job to another machine which has the same portion of the file which was there on the dead task tracker. Okay. Okay, so this is what is the role of a task tracker is, a job tracker and a task tracker. And this is what the Apache 1.0 was. So job tracker and name node, they they basically are communicate with each other. They know each other. Job tracker knows the address of the name node, and job tracker asks name node, hey, which all machines have the portion of this file, and accordingly it will send only on those data nodes, because on each data node the task tracker is running. So it will communicate with the task tracker running on that data node and then do the job. Although the name node and job tracker can sit on the different machine, and they need to know each other. At least job tracker needs to know, not each other. Job tracker needs to know the name node. Okay. Was I able to answer your question? Hari, Chintamani? I'm going to make a backup of all your comments also, just like secondary name node, so that in case I need it in future, I can refer it back to. Okay, great. Now, now this was the older architecture. Now, problem with this architecture was that the task tracker used to perform only the MapReduce job. Task tracker used to perform only the MapReduce job. Right, right, right. So, okay. So here, the problem was that task tracker used to only execute MapReduce. Okay. And because of which, there were a lot of other extensions which were not possible. Also, the role of job tracker was quite high. So what people came up with a newer framework called Yarn. Similar to task trackers, they have task tracker of each individual service which sits on each of the machines, and they negotiate with the main resource allocator. So let me put it this way. So Hadoop 1.0 was designed such that the only unit of distribution of the work only unit of the distribution of the work was MapReduce. But later point of time, people figured out that MapReduce is not the only solution, and there are a couple of use cases in which MapReduce is not able to help you much. For example, a graph search, or uh, or the other complicated uh, queries. In those cases, MapReduce does not help you much. It does help, but there are better frameworks available. So, and also for other, there were a couple of more examples because of which they realized that this distribution of job should be anything. Okay, you can create your plugin. You can create your plugin, and then so I'm getting a ping from, I don't know what I'm getting from. Okay, this is fine. This is fine. Never worry. Okay, 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 okay. Right. So basically, it keeps informing me with a ping that somebody is joining, somebody is joining. That is why I was getting that sound. Okay. So basically, to do the job of a task tracker, but in a configurable way, you can create more of the kinds of task tracker who can do different kinds of jobs. That is why a newer framework was created called Yarn or Hadoop 2.0. Okay. So earlier there was HDFS. On top of it, MapReduce was sitting. So MapReduce jobs were getting distributed all across HDFS. Now everybody needs the job. The task distribution onto an HDFS. Basically, you have to take a processing to the each individual node near the data. Now earlier, MapReduce was the only way to handle that. Okay, but people realize that the MapReduce is not great for for few use cases. So why don't we make it a little bit pluggable? Meaning, MapReduce be just one use case. Okay, and there are other data processing engines. So the that's where Yarn came into between. Yarn's job is that it will distribute and it will communicate with all the guys, and it is possible to create a newer kind of servers. So you can take a look at this. So for example, giraffe is one graph search algorithm. It is possible to write the whole Google PageRank algo in around nine lines. That's what they claimed. To write the same algorithm, it takes a lot of effort in case of using MapReduce. So basically, MapReduce became just one customer of the distributed computing, and you can use all of these kind of you can code your application using various kinds of system. And the full form of Yarn is yet another resource negotiator. Okay, and this is where this is sufficient to know that these are the portions which got divided into these portions. Okay, do not worry about it right now. Only thing to understand is that what task tracker did for MapReduce, you can create when you are creating newer surveys similar to MapReduce. It is now possible. Similar to task tracker, per application tracker is going to be there. So MapReduce task tracker is one, and then you have giraffe task tracker, and those kind of things you can keep on creating. Those are what is known as per application application master, and there are per node slave manager. So these are the various kind of things. Okay. So Yarn basically helped you support for other than MapReduce. That was the main reason. It helped in scalability. And also the important aspect is that whatever MapReduce job you had earlier, they will still run if you upgrade your Hadoop. The only thing you will have to do is compile and create the jar again and push it. That's it. Nothing more is required. Okay. So these are the few features which were done, and we will cover Yarn again. So do not worry about this aspect. And this is a vague diagram. I will describe this diagram in another session. Right now, most important aspect is that the task tracker which we see right now is has been, for this was only for MapReduce. Now it was possible in Yarn and Hadoop too to create similar kind of task tracker. I mean, those who are implementing a new paradigm of programming, say Giraffe and other people who do a graph search and HBase processing and all those kind of things, they can create their own kind of application manager, which will be parallel to what task tracker was for MapReduce, and hence it is possible to extend it further. So there is one common paradigm called distributed computing. Distributed computing means take any code, execute it across. That is one way. Okay. And now this code becomes easier to manage if this is in map and reduce. So this is how it is. So right now I'm skipping this particular slide. We'll come back to it when we discuss Yarn in detail. Okay. So Yarn is called yet another uh, resource negotiator. Basically, it has two portions. Resource manager has got two portions. One is for scheduling, other is for resource managing, and that is why it is called resource negotiator. Okay. And the other reason is for the namesake, that the word should look nice and good. But this does a good justice. Okay. Scalability in the sense of since there were gochas in the older way of doing things, when you started overloading your task node and name node. So the single machine, which was this if you see, the job tracker was overloaded. So lots of things had to be moved to the each individual task tracker, and that's where the whole architecture moved like this. Okay, there is something called node manager whose duty is to manage the nodes, and there is something called application master. Application master is equivalent to MapReduce master. Application master is that this master is going to take care of one kind of applications, and the blue one is for another one. So I'll come back to these things again and again. Okay, so right now you do not have to worry about any of this. Okay, we already had a lot of architecture things. I think it's a time to go for the more hands-on. Yes. So you are right, Gaurav. There are separate task trackers for MapReduce, Spark etc, or it's just separate instance. So these are now called application masters instead of task trackers. Okay. So do not worry about it right now. Okay. Let's just move on. So first, I'll just go take you through the cluster setup, which we have done. Okay. And before that, I don't think you have any questions. Okay. So let me take you through the cluster. So when you log into No Big Data, so how many of you actually did a How many of you actually went through the sessions? Basically, nobigdata.com's website. Okay, great, great. Shashank has gone through it. So you are not able to SSH to the cluster? Okay, okay. So Hari has downloaded VM. I would say that you try both the things and you keep VM ready as well as have the online system ready so that you can keep on trying stuff. Okay. So here I have installation instruction. So when you try to do that, let me try to do that once. Basically, you need to say student. I'll just increase the font. Okay. Yeah, I'm able to log in. Okay, maybe your network is not allowing. Okay. So basically, there are two ways to manage a cluster using the command line, as well as there is a beautiful interface right now. If you go to see the what we have done is we have installed the Cloudera Manager. Cloudera Manager is a way of handling the cluster. So can you see the screen? So this exercise is not to, the objective is not to take you or overwhelm you with the information. The objective is to just give you an overview, what is where, so that you can start exploring by yourself. Okay. In case you want to experiment on things like configuring and administering the node, let me know. I will provide you with the access of the administrator user of these servers. Okay, I'm not afraid too much about its setup because I have a backup of it and I can restore it. Just that it might be a little inconvenience to other people. Okay, so right now, this is what it looks like. So this is the main status. It keep on showing these critical health issues. These are basically your DNS resolution. Oh, that's nice. That's nice. VM Heartron. What is VM Heartron? Okay. So, okay. So here it shows that you have got these nodes. Okay, okay, great, great, great. Okay, great. So Anto has already handled a word count program using uh, a virtual machine from Horton. Hortonworks, I think you must have done from Hortonworks. HORT, Hortonworks network. Okay. See, so we have got these two nodes right now. We'll be adding more nodes as in WAN. Okay, these are the various roles of each of these nodes. Okay, on this a name node is running, a secondary name node is running, a gateway is there, a Hive metadata store is there, and there's an event server, there's a host monitor, there's a UG server. All of these things have been installed. Okay, it shows bad health because of certain DNS issues, which I'm trying to resolve it. And and then there's something called on this one is this Hadoop one is a high end machine, and this one is a low end machine. This is a four processor. This is a single processor, and it has got a data node, and it has got a basically the task tracker in it. Okay, this one. This one is for MapReduce, and there will be another one later point of time. If I install it, that will be for this. So right now, our job is not getting hampered because of not knowing yarn, because here the whole terminology is intact. There is a job tracker and there is a task tracker. Okay, there is a data node, and there is a name node, and there is a secondary name node. So this is how you see all the nodes. If you have to tomorrow when we are buying more hosts, we'll just go to hosts, and then we can say add new hosts. Okay. And this add new host wizard will start installing hosts and installing all the software required on those hosts. Okay. Now let's go back to home where we were. So this dashboard shows you all sorts of things, and I will come back to these things quickly. So this is how your CPU looks like. So CPU usage is almost zero because none of you have used it properly. None of the jobs have been run yet. And then we have cluster disk IO, and these are the disk IOs we are seeing. And then these are HDFS IOs, which are very, very low. If you see, it says 1.5 bytes per second. Okay, great. So, and we have got cluster network iOS. All of these are there. Now, here there's everything. Let's just start going to each one by one. Let's first go to HDFS. Okay, because HDFS is the base one. Now there is a tool called Hue. Okay, Hue provides you access to a very beautiful UI from which you can manage the each nodes. Okay, here this is a simple UI provided by name node itself, where it shows you all the details about each one, and you can also browse. This is little ugly. I'll show you a better UI under Hue. Okay, charts library configuration instances. There is a data node, name node. Okay, charts library, and okay. This is our name node. Fine, fine. And let's have a look at. Okay, so first of all, my objective is to give you. So there is a very nice tool which is called Hue. Hue gives you a great way to handle a lot of things. Okay, so we have got under Hue is a nice UI. So the UI which Cloudera Manager provides is for general administration, while Hue provides you a beautiful UI to interact with each of the things, such as, say, we have got Impala, Pig Editor, file browser. So let's look at the file browser. This is the file browser. So this is the HDFS we are browsing right now. Okay. So you generally create your input output folders. Output folders you don't need to create because it will be created automatically. And if it is there, then it will give an error. So right now I just created a folder called word count. On that I had uploaded these streaming jobs and had put it. So you can quickly upload a file from here from the web interface itself. So this makes it very easy for the beginners to start. Okay. Similarly, So this is how you can, quickly click on files and then say zip file and upload your files here. And as a practice, all of you create your own folder under user student. Okay, you create your own folder as a practice, and then anything you upload it there. Okay. 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 For Arun, the page is not changing. Okay. Okay. So maybe for others it is changing. He is still seeing a chart space. Probably you need to disconnect for a second and then connect back. Or what else could be done? For others it is changing, right? Yeah, yeah. So you probably just disconnect for a second and then connect back. Okay. So he's saying that uh, upload a file. So I'll just upload one file for you and say, let's say I'm planning to upload a nice thing today. So I have got my Dropbox. So I was actually working with a company called Your Cabs, and they gave me their data today to analyze. So this is a huge, I mean, the GPS coordinates. So this is nothing to do with the experimentation. So it'll upload it here, or I could have actually uploaded something else which could have been done quickly. So we have something called, say, this one. Okay. Oh, this is still bigger. Let me just upload this one. This is done. So file.txt should generally come here. Okay. So upload files and then okay, select files. Okay, this is what is getting uploaded, or maybe so this the file.txt is empty. That is why it's giving error. And okay, I don't have a file in which. Okay, okay. So, so I think it is uploading something. Yeah, it has uploaded already these two files. You can see, and also this one it was uploaded, partially. So it has kept that one also for us. That is nice. This also was uploaded partially. Nice, nice. So I can just move it to trash. So this way you are basically interacting with the HDFS. I will also show you the commands how to interact with it. Okay, okay, great. So everybody is working together. So he's also able to create, these are the files created by Chintamani. That is the beauty of using a cluster, because all of us are able to. So here what you do is create your own folder under this. Okay, you say new and then say directory, and with your own login name, basically whatever username you choose, you create that one so that you don't intermingle each other's data. Okay, because all of you will be actually working on the same folder structure. And that's the idea about HDFS, that it is going to be a single folder structure for all. Maybe your folder is created a little level up or down, but this is slash user slash student. Okay, great, great. Yeah, so basically I'm planning to use the same login ID for all the candidates right now, because that makes it easy for each other to even examine each other's work. Okay, and as a etiquette, let's not damage anybody else's data. Okay, and whatever is your folder, like Hari has created his, B Kumar has created, so that I can also quickly examine everything. So this is how you're interacting with the file browser, and I'll also show you the command line how you interact with it. Okay, and similarly you have got something called pig editor here. Okay, so in the pig editor, what you do is, okay, I have created. So you are able to see the web interface and SSH. Should I show you how to connect from SSH? Okay, okay. So all of you are able to do it. So let me just do it for the sake of other part. So what you do is you do SSH and then student hadoop1.nobigdata.com and then you log in. For me, a good idea also is to add your SSH keys. If you search for how to add your SSH keys to a remote server so that you do not have to provide the login password. The way it did not ask me for login password, you can do that. Okay, all you need to do is generate keys for yourself and then add those keys into SSH known hosts. You can find it like passwordless SSH access on Google, and the first link you get, you just follow that one. So this is where, this is my local folder. This is not HDFS. Okay, this is my local folder. Okay, now to access HDFS, all I have to do is Hadoop, and then I say file system, and then I say ls, and it should show me the directory listing of the my home folder in the HDFS. This is my home folder. Okay, which these are the all four files created. So all I did was Hadoop fs minus ls, and this is what you get. So if you have to make a directory out there, so you say Hadoop fs make a directory, my personal directory, okay, and it will create the directory remotely. Okay, and so let me have a look at if does it accept it that way. No, it doesn't. Okay, so this is my personal directory is created here. Okay, and if I have to upload something into my personal directory, all I have to do is, okay, so this is, I mean, you copy the directory from here to there, then this is the command to use for copying there. So Hadoop minus fs, Hadoop fs, and then you say move from move from local, and then big text. Okay, and then say, and then I want to say that store it remotely in my personal folder. Okay, now if I say Hadoop fs minus ls and say my personal directory, it should show me all the files inside it. If you see, okay, okay. So this is how you interact with the from the command line. Local directory is your the folder from which you did your Hadoop command. That is the local directory. I can see your B Kumar directory here. If you see capital B Kumar. Okay, wait. So when you use server name but not working with IP. Okay, 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 great. Anybody has a question here? No, B Kumar is not local. B Kumar folder is not local to the host. It is existing in the HDFS. So what you do is you say Hadoop minus fs minus l. Hi Arun. So Arun is now finally back after 5-10 minutes after trying a lot. So I'll just do a little bit of recap. Do not worry, you do not lose much. All we talked about, there is a web interface using Hue, okay, in which you can explore the files. And here there is a file browser in the Hue. If you go to Hue and then you go to here, I've also mentioned this link in the in here in the manual also. And then you can create here. So everybody please create their folder under user students folder, okay, and in which you will be pushing your data and experimenting on it, okay. And we'll be having around 500 GB of space on HDFS, and we'll be keep on increasing it as the class proceeds, okay. So this is what is a file browser, where you can keep on uploading your data for experimenting on this. And I was showing you that there is a, after you SSH into into the server, you can do, this is my location where I SSH, and I do Hadoop minus fs ls, not minus fs and minus ls. So this shows my home folder, which is user and student. Okay, so his question is that how do you change? Okay, so these are all talking to each other right now through a command called Hadoop, Hadoop FS. Okay, and you can actually mount Hadoop file system HDFS like just another file system. If you use Fuse, there is a mechanism called Fuse with which this will be visible as if it's just another file system to you. Okay, now here say ls minus l, and you say you say sorry, here one question was that how do you change directory there, okay. So it doesn't mean by anything by changing the directory, because every command starts afresh. So you always specify either the absolute directory like this user dot student, okay. And to copy anything from local or move from anything from local, what you could do is use this command, okay. Or if you say cp, here, and then you'll have to use file this way, okay, and then you write your file name, local file name. This is how you type your local file name, okay. So this is the basics of Hadoop file system, and this is good to know in case the Hue is not available. Otherwise you keep on using Hue, okay. So let me get back. So we are able to make directory and copy onto HDFS. And also when you are using command line like Hadoop FS and all, you will have to first copy your file onto this server Hadoop one dot here, which using SCP. Okay, so that makes it a bad choice mostly, because any content you want to copy to Hadoop, you'll have to first log in onto this machine, and then use Hadoop FS. Okay, so that's why a file browser is a better choice. Okay, but you must know all of this. So Hadoop is the basic command, and the secondary command is fs, or if you don't provide fs, then it thinks that you are trying to execute MapReduce. Okay, and for more help, you start going through it. Okay, so let me have a look at somebody's question. Large data for failed to upload. Okay, do not worry, yeah, we'll see to that later. And yeah, you can execute your MapReduce command just like any other thing. And let me show you how do you, interact with it. So let me go to home. Then we have Impala, the big editor, Meta Store Manager, Scoop, Job Browser, Job Designer, Oozie Editor Dashboard. So let's have a look at first Oozie Dashboard. Okay. So this way from here, as we discussed in the class, this there is something called Oozie, which helps you create workflows. Okay, in the Oozie, basically, what kind of workflow can you create? So I clicked on create, and I'm giving it a, say, class training workflow. Okay, and here is shared. Let's just make it shared, and then I do not worry about this. So I'm trying to create a newer workflow. Now this is a nice screen. Okay. So any work you do on Hadoop will be a combination of things like your Java code, your pig script, your Hive script, your scoop, shell. It might be a combination of one or more of those. Just a second. What was the question? Do we have any format on the file, text or zip file? How do we convert files into tables? So right now we are only talking about a file system. We are not talking about a database, Anto. So you can, HDFS does not have any restrictions on what you are uploading onto HDFS. So you can keep on uploading anything onto HDFS right now. So Vivek's question, can you please clarify the local directory again, how to copy file from local machine to HDFS? So to first, there are two ways to copy your files from local machines. Okay. For basically, first, from if you are running on the local, first, say will have to copy the data from your machine to hadoop1.nobigdata.com using SCP. After you have copied that data, you will say move file from local directory to Hadoop. Was that your question? So the way I had done here, I'll show you here. Yes. Okay. So yeah, here this way you say Hadoop FS move from local, which is there, to the remote. Okay. Local machine is server, right? Yes, yes. So here, when we say local machine, we are actually logged in right now in Hadoop 1, which is local. Now this local is basically nothing but your default Unix server. It is just that this machine is remote for you. Okay. So first you take your file from local machine to this Hadoop one. From here you run a command called Hadoop fs, then move from local to Hadoop HDFS. So HDFS is installed on the Hadoop one. Okay. Okay. Now let's just move on. Thank you. So Vivek has got his answer clear. Okay. Okay. So yeah, I mean they are almost all the same things, just a minor things. In case I move from local, local will not exist. And there is something called CP also, which copies the same thing. And probably the easiest thing to do would be using this browser. Under Hue, if you go to the file browser, probably this will be the easiest thing because it involves a singular step. The only downside of this browser that in case your file is going beyond a certain limit and browser is not able to handle, in those cases you will have these two steps. Okay. Okay. Because browser has certain limitation on the file size. I'm not sure if it is there right now, but few years back it was, because browsers are evolving every day, right? Now, I was talking about, we discussed in one of the slides in the session one that there's something called Uzi. Uzi's role is to create a workflow. No, no, that will not be an issue, Bhagvat, because if you, what kind of file are you trying to upload? How big? So let's have a discussion maybe tomorrow or after this session, immediately after this session, and examine why exactly is it failing. Okay, why is it failing? I was able to upload the same file and run bson actually, and it was successful. Okay, I'll try it again, I'll check it again, no worries. Okay, moving on now here. So we were talking about creating workflow. So we went to Hue and said add workflow, and this is where we end up. So workflow has got 2 points, start and end. And under this, you have all these things. So you take a MapReduce here and put it here, okay, into this dashed area. And this is what pops up. So in this, you give a name, say to your job, some word count or something, and here. And after that, what you do is you upload you select your jar or upload a new jar. Okay. Uh, Either you select a file here or you upload a new jar, and jar will contain your MapReduce logic, and then you can add all the files which you want it to operate upon. Okay, you can add all these things, and also add the property name. Property name is which one is input file and which is the output folder. So those kind of things you can define from this interface. And then once you are done, you say submit and it runs. Also, you can combine these things together like a streaming job, shell, SSH, email, workflow. All of this you can combine together to create a workflow here. Okay, so this is not the only class. There is a separate class dedicated to Uzi also, and we will uh, describe it later also, but this is just an introductory session so that in your free time you can start experimenting and exploring these things. Okay, so let me have it's asking for you give the same student and that password, and that will be sufficient. Okay, so try with the same login password. I think it should work. That's what I defined. Generally, you should ask for password when you open Hue, say remember it and give the same password. Then it will work. Fine. So this is your nice workflow editor. Okay. And we have got home folder here. Yeah. So, Oh, Arun, you lost again. Anyway, so we were just discussing these hue files. Okay, and in this you can also create tables. Okay, into the HBase, create new table from the file, create new table manually. Then these tables are going to get created in the HBase or Metastore. Okay, so here is your folder. Excellent. Now pig editor. So as we discussed in one of the session, in the first session, we just said one word about pig. That pig is just another scripting language. Sure, Arun. There's nothing that you can't pick up. Okay. I just hope that this doesn't happen during MapReduce session. So here, let me go back. Yeah. Okay, we are here. So let's see how does a pig looks like. Okay. So I had already created a file called output something, and then I say a equals load and then this file name, and I define the data type and this. Do not worry, do not panic if you don't get anything out of this. The whole idea is to describe, give you like, see, this is what it is. Okay, let's just save it, and let's call it something. We call it hello world. Okay, so this is how generally pig script looks like. If you cannot see it, I'll just increase its size. So it's more or less like your SQL. I'll come back to that, Gaurav. Just give me a second. So here you can say load this output file into this variable. This is nothing but a set of these two things. Each this is a this kind of thing. It's a row, various rows of these tuples. Tuples say f1 is this and f2 is this. Okay. Now let me just run it. Let's see if it runs. If it doesn't, then we'll try from the command line as well. Okay. So as we talked about that anything we do, it is going to create a MapReduce job on the pig. And this is what is going on in the background. We said execute a command which will load a file which contains two fields, um, and it will load that as a set which we can iterate over later point of time. So it says it's running. So here, this is basically under the hood, it has created a workflow which has got a pig in it. Okay. And let's see if something comes out of it. Is it not possible to run it? Okay, let it finish. It's already running. Okay, let's see if something comes out of here. It doesn't killed or something. So you can check the what exactly is going on using that log there. Here it is. So it is doing something. It's saying sending heartbeat again. Okay. Does that file exist? Let's just try that too. Where is my... Okay, it is Gauss. Okay, so I think it is stuck somewhere. We'll continue and we'll come back to it once it is done with something. I think there is something wrong with all of these things. I think one of the hosts is down or something. I'll review the settings again. Okay. It has been crying that the health is bad, but I thought it just fake alarm because of the DNS settings. Let me just see if the pig works here. So I said pig from the command line and let's see if this works. Yeah. So it says grunt and then I said a, and when I say dump, so I same command, I can go to the command prompt from the SSH after doing SSH, and it can take the you run a command called pig and then you uh, type your query and it will run it. So it's actually executing in the background. Okay, so this is how you execute most of the scripts. Not exactly this is the way, because this is not really working. It's taking forever from the command line as well as this one. Probably I need to review my data node. Data node is down, probably. Nevertheless, moving on. And if it finishes, then I can actually. Okay. The other part I wanted to show you. So this one is basically executing any query. This is a query. This is basically a query which loads a file. We will discuss in detail these things. So do not get worried if you did not understand anything. Okay. Right, right. There will be a complete class for pig separately, 3 hour session. And then this is Hive. This is what it looks like. Okay. Not really. Let's take a break after some time because I'm not even halfway through actually. I'm moving a little slow. Okay, just so let's take a break after 5 minutes. Yeah, yeah. So all of these topics are going to be covered later. Okay, right now it is just a small, kind of a demo in which I'm trying to tell you that, hey, in case you want to skip ahead and move a bit before me, you can go ahead and start hands-on with these things. So this is how you, from the command line, you say Hadoop file system and then say cat this file. This will bring the data and store it in frequency. Okay. And frequency table is nothing but a name and it's a number. And so when we say create table pokes and we say something, this is what is called meta store. Okay. This is what is called meta store. It is storing it in the meta store. Okay. And then we say load data into this pokes table from my HDFS file. Okay. And this will load the data into your pokes folder and then you can say select star from pokes. Okay. Oh, it's all stuck. It's all stuck. Never mind, we'll just kill all the jobs. Okay. So see, if you see, all of these have been converted into MapReduce jobs and are getting executed. Okay. I want to kill all of them, so I'm just killing the first one. I said yes, so why not now? It's done. First one killed, second one getting killed. Go, go, go. So somewhere things are stuck. I'll review all of this. Yeah. In this setup, we are using Hadoop one node to submit pig Uzi jobs, which is our name node plus job tracker. We are treating as a client machine, but in real world scenario, client machine is separate from name node. Right. So basically, in those cases, you will have to install a Hadoop locally also, the Hadoop client locally also, and then you say that you're connecting to that particular machine. Okay. So, but as a practice, most of the people actually log into the web interface and schedule their jobs from there. Okay. But most of the HDFS job is done from the command line. Okay. Right. Now this I have killed. Okay. Fine. Because these servers will be available for the whole due course, so it will be great if you all of you start experimenting and utilize all of these resources better. Okay. And that is why I want to take you over to all of these. So Hive also similarly, you can go to command prompt here and say Hive. Okay, so VM is dead. Anyway, we'll just reboot this machine. Let's just go to this, and we have already killed all of the jobs running. There's no running and everything is killed. And let's go to Cloudera Manager. What is the status? Okay, Hadoop 2. Okay, Java heap size of in bytes. Okay, anyway, these issues I'll take a look at it again, and if required, we'll buy more machines or bigger machines. Okay. Now, so in case of Hive, you can try by yourself this command, okay, whereby all I'm trying to do is trying to load a file into a meta store of Hive. Hive also provides you a meta store. Meta store helps you communicate across the databases because every database has got own structures. So the Hive talks in terms of database tables. For schema-less table databases, it maintains the schema for them also. Okay, this is a simple, quick, very quick MapReduce, and the example which is there, I was, you can execute this command to run. Okay, so first of all, the output directory you plan to give, you should delete that one. Okay. Oh, it's dead actually. Okay. Okay. Okay, somebody has eaten up all the space. So anyway, so basically the whole idea of executing a MapReduce job is like this. So you go over to the command prompt and say, first you create your MapReduce job. It can be into three format. First, it could be in the Java, okay, or it could be any of the other languages, and even it could be a simple Unix command. If you are using a job streaming job, you can give any binary as the mapper and any binary as the reducer, or any PHP, Python, or any command which can run and read data from the input and give data to the output. You can give any of such command. Even if you are a good programmer in the shell, you can do write a MapReduce in the shell. Okay, so that's the whole idea. In case you do not know any programming language and you know only like Shell, Perl, Python, any of these scripting languages, or you have done your C programming somewhere earlier and you are comfortable with C, you can do all of that. Thanks to Hadoop, Hadoop came up with the idea that we will do a streaming job for all the people. Okay, so streaming job takes two binaries as the command line or two scripts as the command line, as long as on a Unix system you have done given execution permission onto that script, and you have mentioned in the header that this is how it is going to get executed. Then it Hadoop will execute it in that way. Okay, so any file if you run from the Unix command prompt and it runs, you can provide that as a mapper or a reducer. All it requires is your code or script or whatever it is, it should read the data from standard input and gives data to the standard output. While MapReduce in Java is little bit native because whole MapReduce is written the MapReduce and the Hadoop is written in Java, so it becomes little more faster, but it doesn't matter. The difference is only few milliseconds. Okay, but what matters is how are you going to structure your logic? How are you going to structure your logic in order to get the desired results? So that is about MapReduce right now. Since my machine is not running, I'm not able to demonstrate you this, but let's do it again tomorrow, all of these three commands, and move on. Okay. So in the second half, I'm going to take you on a little bit of a stronger algorithmic challenges. Okay. Basically, the whole objective of learning MapReduce is that you should be thinking in terms of MapReduce at the end of the session. Okay. What I have found is most of the people, even though they become experts at Hadoop, they are not able to solve MapReduce problems. And i- but everybody is able to write SQL now after a little bit of practice. The way my assumption is anybody who is able to write MapReduce should write SQL should be able to write MapReduce logics. It should not be that big a deal. Okay, so it just requires a bit of practice and bit of looking at various kinds of problems. So that is why I am dedicating more than 1.5 class to MapReduce. So and these kind of basically people focus on MapReduce only in case of data sciences classes. Okay, but I'll try my best that based on my past experience, all of the candidates have been able to write very decent map reduce jobs and able to convert their logic in terms of maps and reduces. Okay, so after the break, we'll continue with our map reduce. Okay, in this setup, we are running using. So, was I able to answer Gaurav your question, or should I repeat before taking a break? Okay, great, great. And I wanted to collect verilog log files for MapReduce. Which tool do we use? For MapReduce or with MapReduce? Basically with MapReduce, you want to collect all the logs gathered. So generally people prefer a tool called Flume for I think it's Flume. Yeah. So they use that one. Or Impala also does the same thing. Okay. But whenever I've churned the Apache logs in my past, I simply use my streaming jobs and used straight away HDFS, and it did work well. Okay. It's just that you need to a little bit of tweak things by your own way. I wanted to parse the logs in my own way. I wanted to detect whether the requests are coming from somewhere in US or somewhere in South Africa. So that's the reason I had written my own MapReduce jobs. So for parsing the logs. So in case you do not want to do a specific parsing, you can use the existing log systems. Okay. So this problem we are going to take up seriously in the second half. Okay, and Let's meet after 10 minutes, which is 10:19 for me. Okay, okay. Let's meet at 10:19 or 10:20. In the meantime, think over this problem which I'm leaving you with. Hi guys, I'm back also. So let's start. Already 2 minutes past. Great, great. So the question which we were trying to answer is this. Okay. Or do we need to wait for somebody? Hey Chintamani, are you back? I think not everybody is back. Okay, great, great. Vivek is back. Shashank is back. Gaurav is back. Probably Chintamani has gone to have his dinner. Okay, okay. So let's start and he'll catch up anyway. So if you have a plain text file of all the LOTR books, okay, I'll just put the also here, the, otherwise they will be. And why I have kept Lord of the Rings is because they are huge books. Okay, if you have all five, I think five books, right? So if you have five books, LOTR, and you want to find the frequencies of words, and this is a simple open-ended question. And this is the objective that, hey, we need to figure out the various frequencies of various words in these books. So, what are you going to do? What are the things you're going to do? Okay. Hey, Sukhavat is back. Suksavat is back. And let's start with. So, my question, Suksavat, was that if you have a big, very, very big files of plain text, and very big in terms of plain text is hardly 20 or 30 MB. 20 or 30 MB will cover all the five books of LOTR. Okay, but they are quite huge, or maybe say 50 MB at most. Okay, how would you find the frequencies of words? What are the steps are you going to take? Okay, I'm waiting for your answers. Okay, so I'm waiting for your answers. Like, what is it that you would do? Okay, okay. Load the files, break words. Okay, then basically break by space. Give me an approach. Give me an approach. Using SQL, using your own code, using a Python script, shell script, or how are you going to do it? Using a Unix script. Okay. In Unix, yes, carry on, Sashank. I'm looking forward. Okay. So Bhagwat, you are a step ahead. By the way of this, Bhagwat has also attended our MongoDB classes. Okay. And so he's aware of map and reduce. So do not get worried. Hari says that he will use a Redis, okay, or Memcached as big table, okay, okay. And why do you need to do that right now, Hari? Okay. So it's a very simple question. It's a very simple question here. Say you are given a big file containing plain text, and you have to find the frequencies of words. What are the things are you going to do? Okay. So Gaurav is saying in a normal program, parse the file for words, then use a loop to maintain the count of each words. Use a loop to maintain the count of each words. I mean, you will have to keep the all the words encountered somewhere in the memory, right? Because there will be a lot of words. Okay. Anybody else? I'm looking for a Unix kind of approach. If somebody can give me in Unix, what will you do? Or in SQL kind of approach, how would you do things? And so Gaurav's approach, I got it. Okay. So feel free. I'm just waiting. I'll give some time. To, you have a lot of plain text. Okay. And you want to count the words. Okay. Let's not worry about things like S, ES, or you have a full stop at those things. Let's just say that we have something called a cleanser. If you give it a word, it will clean that word. So let's assume that all we have to do is if we split this text with a space, it is good enough. Okay. That will give you the words. And then we have to count the frequencies of the words. Frequencies is the number of occurrences. Okay, number of occurrences of each words in this plain text. I'm waiting for the answers. Okay, okay, I got from Kalyan. Kalyan says split the file based on space, perfect, and then load into a separate file, sort it, write a program to get the word count, that is number of occurrences. Excellent, excellent. Yeah. So, okay, so Kalyan, could you a little bit more get into nitty-gritties? Yeah, okay, I got it. So Chintamani says cat file and then pipe it to sort and then unique for each word. Or you can just say unique minus C, right? Great, great. So basically we have got various kinds of approaches. Okay. Here, let's just go over one approach at a time. Okay. And feel free, if you get a newer approach, feel free to, say it. Okay. It is because it's an open-ended question. There could be infinitely many solutions. Okay. There could be infinitely many solutions. Grep word to text file, yeah. And then WC to count each words. Okay. 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 Let me just think over it. So grep word to text file. But then how do you know that what all words you would have to grab? You'll have to first take out all the words, then iterate over each word, and then you look at grep that word into the text file, and then run. You are saying something like, how should I describe? Okay, how should I describe? But if you see, Sukhsavat, there is one more problem with that approach. If because if you are doing a grep on a text file, it will result in the lines. And if it is resulting in the lines and you are doing word count, you will be counting the same word multiple times, isn't it? Okay, but this is a different approach. I also need to think a bit more. Anto says that load the file. Suksavat, feel free to actually share your share your response to with all the people, not only to the organizers. Feel free to share it with all the people and let everybody have a look at each other's approach. It opens up everybody's way of thinking. Okay, the more ideas you get, the more newer ways of thinking we get. So I actually prefer to look at lots of solutions to the same problem. I'm a programming Perl kind of a guy. If you have heard about a book, Programming Pearls, or so I like that kind of way of explaining things, and that is why I love lots of different kind of approaches. Okay, so Anto's suggestion is that load the file filter by word group. Load the file. Load the file. Filter by word group. Filter by word group to count. Give me step by step. I think I'm unable to figure it out because you are maybe you are writing as you are quickly, very quickly. Load the file filtered by word group. Okay, okay, I got it, I got it, I got it. So basically, you are saying that, yeah, this is one of the solutions I was expecting. Okay, great. So now let me also and any other solutions, sir? I'm looking for solutions from all the people. You can, even if it's random, I would love to have that. Okay, very very random also. Completely literal also. I will love to hear that. Okay. I could only come up with three solutions. Okay. So grab, file, and WC. Okay. No, but how did it work? hmm hmm I'll have to think about this interesting approach. But I did not understand it quite. Have you run this command? Because I did not understand it. Because grep needs a keyword from somewhere to search in the file, and file is to be concatenated. Okay. Okay. Now let's go over each of these approaches. Probably we have covered all the three approaches. So my first answer is that programmatic one, the one which Gaurav said, that create create a sort of a memory where you keep a record of which word you have encountered. Now start reading this file. Okay. 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 That is something sort of a solution what you have given now, Gaurav. And then yeah, we'll discuss that one again also. So first one is to break the uh, go over the file as soon as you encounter a word. You check in the hash table. And for those who are not aware of a hash table is, you can imagine, like a dictionary, which is a sort of key value pair. And the read and write from hash table take a constant fixed time irrespective of how many values are there. Okay, and it's the de facto approach of saving a unique value and retrieving saving a unique value and retrieving a value for the key. Okay, so hash table is nothing but an analogous to key value pair. It's heavily optimized for key value, and it is like an array. The way you have an array where you give indexes like 0, 1, 2, 3, and you get the value. It's a similar thing for strings. If your indexes are string instead of integer, so the way you access something from an array is, or from a random access memory is, You give the location as a number and it gives you back the what is located there. Similarly, hash table gives you the response in terms of if your index is either string. Okay, so I'm saving the more details for later. Now, for each word in the file, you increase the frequency in the hash table. Hash table is for the frequency hash table. Create a hash table frequency, okay, frequency hash table, which will have key as the word and value as the number. And as soon as you read a word, you look up in the hash table. If it is already there, increase its number by 1. Otherwise, uh, add a new value with the default value as 1. Okay. And at the end of it, when you are done with everything, when you're finished with the uh, reading your file and your all the words are finished, updating the hash table, you just print the hash table, and that's it. So this is a pretty simple approach. Uh, I mean, this is a very basic approach where you just started reading your plain text file and kept on updating a variable, which is a hash table, to take care of this thing. Now, this will work just perfectly fine. Do you see any problems with it? Do you see any problems at all? So all you did was read the file, kept the record of what all words you have encountered, how many times so far, and kept on doing it. And remember that hash table is in the memory. Okay. So what exactly is the problem with this approach? Okay. Yeah. So Gaurav says and Hari says that memory issues. If the file grows beyond your memory, okay, if your file goes to GBs, and since hash table approximately takes 4 times the memory you are trying to store in it, then you are going to get a lot of memory issues. So if you are storing, if you have say 100 GB, I mean, in the best case scenario, I haven't met a server beyond 100 GB data. And if you have 25 GB RAM, then this 25 GB file, then your RAM is going to be insufficient. And hence, you cannot do a count. And those who have a bit of time, uh, those who have a bit of time, they should definitely go over one of the recommendation challenges I faced when I was building a recommender and I had to feed the data to Mahout. And the problem was exactly this. Problem was exactly this. I encountered the memory issues. Okay, I encountered the memory issues exactly for this reason because I was maintaining a hash table and I was not doing it using the MapReduce. Okay, though my rest of the jobs were in the MapReduce, just one portion I thought that I'll be able to manage using this approach. Okay, and that's where I got blocker. So if you have a bit of time, go over my over our blog on the no big data and you will see this thing. So yeah, so the main problem we face is the RAM. Okay, and it is a huge issue. RAM is the first bottleneck you hit on any server. Okay, and provided you have the whole memory for yourself, and that too you will be using 4 times the total size, which means that you are going to hit as soon as you're talking big data, this approach goes useless. Okay, this approach goes useless completely. And I mean, I give you my example. In case of my when I was building recommender and my application started using 4 GB, they said no, no, you can't use 4 GB. We cannot give you 4 GB on a live system on which other processes are running. So I was told no, you cannot use it. Okay. Now I had two options. Either I request them to increase memory or could invent a better way. And that's where I thought that the whole objective of using MapReduce was to handle these kind of scenario. Why can't I use MapReduce anyway? And I was able to do it in couple of MBs. I'll describe my approach. Now, the other approach which we talked about was somebody came up with the filter idea, that I think it was Anto or somebody. Yeah. Okay. So basically, other approaches break the books into one word per line, and the insert all of these words into a database table, and then run this query. Look at this query very closely. Okay. So, I mean, one more thing before I move ahead, what I'm talking about right now, I've taken a very, very simple example of a problem. And you will be, I mean, I will show you all kinds of approaches to solve this problem. And the whole objective is that you should be start thinking in on the lines of handling the big data. And how do we convert any logic into map and reduce? Okay. I will go slow, even if the class spills over. Do not panic, do not worry. And even if we are not able to cover things in 10 sessions, we'll take one more session. Okay. And in case you get bored because I'm going slow, start experimenting and start asking questions. Okay. Now let's say another approach. You took this whole file, broke, I'm sorry. So you took this whole file, broke each line into new lines, and became a big list of words. Then all you did was imported this whole file into your database somehow, and then ask database to order it. Okay. Or create an index on the word, and then did select word, count star from table, group by the word. Word is my column. Okay. So you have a single column called word and you have count star. Now, do you think this is okay approach? What are the problems with this approach? Can someone? Okay. Anyway, then the third approach we talked about is this. Okay. The third approach, all we did was cat files. Cat file is equivalent to what? Anything which is there in this file. Okay. Files as in file 1, file 2, and all five files containing this novel. And then the all of the data is going to get concatenated and going to go on to the standard output. And standard output in this case is your SED, because you have put a pipe here. Instead of getting coming onto the screen, the data goes to another command called SED. In SED, what it does is it replaces, substitutes a tab with a new line and does it globally for all the things. So all that we are saying, take all the files, combine them together, and then whatever comes out of that, replace a tab or a space. Here there is going to be a space also here with a new line. Okay, I've just put a regex, so do not worry. It only means space or a tab at least one or more times. Replace that with a new line, and you will get at the end of it is a big list of words. Now you feed it to sort. The role of, so these pipes is beautiful. I mean, if you are not aware of pipes in Unix, you should, you know, read it once. Okay. If you have time and you wish to read pipes and you want, you want me to explain it, I'll be more than happy to explain it because I like, I mean, all filters and all of this mechanism. So I would love to explain to you if you want it. Okay. So basically, you are piping data from one process to another. Now you reach sort. So whatever words, big long list of words you got, you fed it to sort. Okay, you gave it to sort. Now what sort will do? Sort will take that data, sort it, order it, and give it to a next command called unique prints all the unique words in this list, and in case you put -c, it will print the counts also in front of each one. Okay, so, so whatever sort gives, unique takes it, unique prints each word and how many times it has come in this thing. So this is one nice way of doing it. And if somebody quickly asks me this question, I will write this command and say ki, hey, you can do it this way. So all we did, we took all these five files, said cat file 1, cat file 1, file 2, file 3 separated by space, and said enter. If you do enter, all the files will be concatenated together and the whole screen will scroll for you. In that case, just press Ctrl C. Now, if you pipe it to SED, and in SED you are saying substitute any spaces with a new line, then all you will get a long list of words, and that long list of words you are passing it to the unique with the C. Sorry, you are passing that long list first to the sort will order them. Okay, now uh, since these things are ordered, which means the same word will be repeated multiple times, and now you can give a sorted list to unique. If you pass a non-sorted list to the unique, then it will give a wrong results. Unique expect you to give the sorted results, and this is so basically you concatenated files, replaced all the spaces, replaced space with the new line, and ordered with sort, and then you counted the frequency. Okay, now the approach 2 and approach 3, they are decent, they are pretty good. Okay, because in case your memory is too high and you're trying to sort a file, in both the cases, the first problem in the first approach was the became the problem, right? Memory became the bottleneck. Second problem, the database one and the sort command one. Here, the sort command is little magical. It does sorting of very large file by splitting them. Okay, so and also you can also specify how much RAM you want to dedicate to sorting. Okay. Remember that you can only sort the data which is in the memory right now. So if you have a big file which can't fit into the memory, you'll have to split it and then sort it individually. And that's what exactly the sort command does. So if it faces a very big file, it will take that and sort them using that. If but you will have to provide a parameter called this much memory I want to dedicate, then it will internally do that for you. Okay, and this kind of mechanism of loading only partial file and sorting it is generally called an external sort. Okay, now, and this also, the databases are also capable of sorting the data and handling the data which is beyond the RAM. Okay, so the database will create a B tree kind of thing, B plus trees, and then you will be able to sort it. So these approaches are nice and good. So do you think any problem with these approaches? Anybody? Okay. If my search word is having spaces, how to handle that? Mm, okay. I mean, when you're graphing, so you can put them around double quotes. Okay. If you are searching for a word, so, uh, Anto is asking a question. So I'm answering that. He's saying that if my search word is having spaces, how to handle that is Lord of the Rings. Yeah. So you can just put double quotes around it if you're talking in terms of a Unix command. So and feel free to chat with the whole classroom. Okay. Because anyway I'll be talking. So do you see a problem? These two approaches, they are decent, SQL and Unix. They are decent in the sense that RAM issue will not occur anymore. Or were you able to understand it? If somebody did not was not able to understand it, just let me know now. Okay. Thank you, Chintamani. I'll go slow. Okay. I know you will get bored, some of you, but I would love to go slow. Okay. And yeah. So do you see a problem with these approaches? These SQL and Unix both. In case of SQL, it was simple. We converted the whole thing into a single column table, and then we did group by on top of it. And in case of Unix, what we did was we concatenated all the files and then replaced the space with the tab and then sort and then unique. So this is the most this approach what we just talked here is the closest to what Hadoop MapReduce does. Okay, and that is why I always like I always like for people to learn a bit of Unix because this helps a lot of kind of programming issues. Whether you are a DBA, you are a QA, everybody, because you can automate a lot of stuff using these pipes and using all of these commands. Okay, so now let's talk about did you guys see any problem with these approach 2 and approach 3? Approach 2 is SQL and approach 3 is Unix. Approach 1, which was programmatical in using hash table in memory, was having the issues of counts. No, issues of RAM. Do you see any problem with the approach 2 and approach 3? Feel free to interact. Uh, I love to answer your questions. Otherwise, there will be no use of the class. Yes? Why did we add tabs? I did not add tabs. Here, okay, okay. So in case the tab /t I added here, right? /t because in case your file has a tab, generally paragraphs start with the tab, just for the heck of it. Okay, okay. Ideally, it could have been like this. Okay, if we think of a okay. Approach 3 might take a lot of time. Yes, it will take a lot of time. Okay. Can you explain the regular expression again? Okay, thank you. Thank you, Bhagwat, to remind me that. Okay, basically, it is a way when you are saying this, okay, it means that space or tab at least once. When you say plus after any of the no, I mean any of the wildcard character, then you say one or more of these. Okay, and what is these? These could be space or tab. Okay, so we are saying one or more times of tab or space, and if we want to put here a comma or dot, okay, exclamation and whatnot, you can say a dash if you want to split it by the dash and underscore, and you can put whatever you want here, and anywhere those one or more of those characters are encountered in the line, it will be replaced with a new line. Okay. Okay. And here there is a thing called slash g. Slash g is globally replace. If there are more than one occurrence of such thing in that line, then also replace it, not only the first one. Okay. Right, you can put a here, but for that you'll have to put this. Okay, put a slash. Now which one? Question mark means question mark. Wait. No, here if you see, I'm saying substitute. So it starts with a command called substitute. Then I say substitute this with that. It's it's like saying control F. Control F, substitute this with this. Okay. Control search for this pattern in the file and replace it with new line. Okay. And yeah, this is how it just the command starts. Anybody else is having question? Thank you, Bhagwat, to help me out. Yeah. It, yeah. Okay. Okay, great. Thank you, Chintamani, to enhancing the answer. Okay. Anybody's having a question? I'm sure you having question because this is a very neat command actually. Uh, okay. So concatenate all the files using this cat file 1, file 2, file 3, and then substitute SCDs. This S is for substituting. Substitute spaces with a new line and do it globally. And once you have got a big list of words, pass it on to sort. Sort is going to take that list and order it. And after that, give the ordered list of words to unique. Unique will find the frequency of it. So this approach, as somebody said, Hari was saying that both of these approaches are going to slow. Okay, right. So we only solved one problem by second and third approach. That was your RAM. If you remember in the first session, we talked about 4 different parameters which will slow you down. Second is network speed. If your file is not in GBs and is in TBs, then your single machine will choke on the network speed if the file is located in HDFS or on a remote file. Okay. Second problem would be the disk space. This file may not, fit on a single disk. Okay. Third is the disk speed, because every time you are splitting the file or doing all the sort of magic, splitting the file and then loading that file into memory, then sorting it, and then writing the results back, and then picking up the next piece, and then reading that one and writing the results back. So all of these things are happening in sequential. You finish with one piece, then pick up the next piece. So this portion, if you see here, this sorting is going to be slow because because what it does under the neath is here you can specify a memory, I think, like this. Okay, minus s or minus some parameter that I can only give this much of memory to it. Okay, I'll just have a look at it. Man sort. So ignore dictionary, month sort, human numeric sort, random sort, reverse sort, both batch size. Okay, check, debug, merge, stable, buffer size. Okay, so you can say minus s. I was right. So minus s, capital S, which is buffer size. Okay, so minus s like this. and this will basically create, out of 1 terabyte, it will create so many files, each of 20 MB size, and sort them individually and then merge them together. Okay. This way, it saves the lot of RAM, but it goes very slow. Or you have, say, decent enough speed, say GBs, but when you do for TBs, it is going to consume a lot of. First, RAM is not an issue, you said. It's able to handle that. A network speed it is going to consume. Disk space will become a problem because it is splitting those files and keeping in the disk and then sorting it, merging it later. Disk speed will become an issue. Okay. Because, so while you disk space is the reason why, because you are trying to split the file, keep it locally, read it from network, or you are trying to put it back on the network. So either of these things will become an issue, and then CPU will become an issue. You have a single processor who is first sorting one piece, then he will pick up another piece and go on. And that is where your system is going to go very, very slow. You are going to I mean, become this is going to become impossibly slow if the data keeps on growing, because all of these factors start playing role. And uh, as you double the size, this speed goes slow by multiple factors. Okay. Now, so what is it that we should do now? So did you get an answer what I'm trying to convey? Is everybody on the same page? Okay, Chintamani got it. Anybody else? Awesome, awesome. Antu is on the same page. Sashank is there. Suksavat is perfect. And thank you. Great, great. So everybody is with me. Perfect, perfect. Now let's move on. Now, what is it? What is it then that would solve a problem? The idea came up that why don't we use an external sort? The way we did sorting by splitting the file into pieces and do it on the same machine. Can we delegate it? Can we repeat the same process everywhere? We all know that we can SSH onto hundreds of machines from a same host and execute the command remotely. Okay, so what I would do in case I have to do the same thing, I will split all these files, put it in the network, file 1, file 2, up to say 5,000 files, and then I will SSH to 5,000 individual machines through this script, and then ask that machine to sort it for me and put it back in a remote file. This is what it's doing. Okay, so you had machine 1 and machine 2. You had splitted your list of words like this already. The first form is over. You are trying to sort it. So what you do is, one first piece, which is this one, this, I mean, and just for the example sake, I'm saying, you gave it to machine 1 and you are asking machine 1 to do the sorting for you. You can do it using SSH. Okay, if you have stored your file in a network server, you can slice it there, keep it there. Second, using you can here, I will just go back to this one. Here, first you split. Now, after you are finished till this point, you take this output, you start slicing it into pieces and start storing it in the network. And parallelly, as and when you are slicing these files, you are launching SSH to sort that file on machine 1, and then machine 2, then machine 3, then machine 4. And once all of these portions are finished. They all the output file, all of these servers have finished their sorting. You take all of these files and say sort minus m, merge all of these files together to form the final one. Okay, that is going to be done on this particular machine itself. Okay, and then you can run a unique command. Since unique does not do any sorting, it goes from top to bottom, scanning word by word, and then it will do the game. It will the moment it hits a word which is different than previous one in a sorted file, it will just print out the statistics and start counting again. Okay, it's like if you're going from top to bottom in a sorted file, the moment you see a newer word from different from the previous one, you just say, okay, this is the count now, and reset your count to again one, and then start counting further. So this is what unique does. So here what you're trying to do is you're asking all these machines to do the sorting for you, because sorting is basically the most complicated task out of all. Right. So, Chintamani, in this approach, what I'm describing just now is that what you did was you split it file by yourself, stored it in the network. Okay. I'm talking about a third approach. It is not really a map reduce. I'm just talking about the fourth approach. Three approaches we talked about. Okay. So in this approach, the sort command we are distributing the sort command such that we stored our all the files on the network, asked our split command to split the file, split the whole data into small chunks, and then using ssh we delegated the work of sorting to thousands of machines and let them store their output into uh, the file output 1, output 10, output 11, output 13, and so on till 5000, and let those all machines work for you to sort it. And then once you are done, you just have to say sort minus m and then merge all of these files together. Sort minus m merges the sorted files. If you have 10 sorted file, you want to merge them into a single one, then you can use a command called sortm, or you could write a simple program by yourself which reads from all these files and then keeps on sorting them. For merging, it's not a very difficult thing, but it is decently complicated. Great. Now this approach this approach where we are trying to eliminate these four problems of a single computer: network speed, disk space, disk disk speed, CPU. The network speed we haven't solved yet anyway. Okay. Now instead of a machine's hard disk or a single machine's CPU or a single machine's RAM, now we are using multiple machines to do the job for us. Okay. And we get these results. So we gave this to the first machine, then we gave this to the second machine. This is a second machine. Hope I did not learn. Okay, that also depends on how many words are unique. Right, right. You are right. You are right. But almost sorting, almost all the sorting, yeah. So when you are merging, when you're merging all the records, the only memory you need to retain is the number of machines you have. Say you have 5000 machines, and 5000 machine created 5000 files for you after sorting your data. Now you read one word from all the machines. Okay. And then you figure out which one is the in the order which one will come at the top, and then spit out that one, and then read from the same machine from which you just spit it out, uh, the one which has got the highest priority, you read the next word from that, and then compare again, and then you can do that. So all you have to do is allocate memory for 5000 words. That's it. Okay. So even though you have 5000 machines, still a merging is taking a very small amount of memory. Okay. And sorting, you anyway have to sort. This is what we did. We sent this unsorted stuff, this to first machine, second machine, they replied you. And then after merging, see, they are in order. RE at the top and SA at the bottom. And then when you're merging, you just go through both the list one by one, keeping track of where are you reading from, and then keep on merging it. Okay. Okay. Is it still echoing? Okay. Great. Great. Now let's move on. Good? Sounds good to you? Till here is everybody. So this mechanism where we did a external sorting is actually called external sorting. Okay. Whereby we split it up files, hand it over to all machines, let them sort for you, and then you merge it together. Okay. And as I described, merge does not need to keep all of these words into the memory. All it needs to keep uh, the words in the memory is equal to the total number of machines you have. Okay, perfect. S- Okay, so each machine finished its job, saved the sorted data to that file. Okay, I'm talking about merging. Now we are trying to merge these sorted files. And the way to merge is read the first letter, first word from each of these files, which is, the topmost or the smallest in ASCII value, and you read from all of these 5000 files. Okay, and then the file which contained the smallest word, now you read the next one from there, and then sort it again. And this way you can find out you can merge very very fast, and it's very decent actually. It takes around n log n again. N log n is total number of words out there. Okay. uh, so do not worry about this n log n thing. Okay. So till here is things are things clear to you guys? I'm going a little bit more into the details, and I mean, this is something I believe that we should know. Okay. Anyway, let's talk about what are the problems with this approach. What are the problems do you see with this external sorting approach? I do not see any problems. Do you see any problems? Yep, yep. So Bhagavad has got it exactly right. That, yeah. So yes, Hari also got a very great point here. Yes. Thank you, Chintamani. Thank you. Okay, great, great, great. So looks like the class is paying attention, and I'm not that boring as it looks to me. Okay, great. Yeah. So now, problem with the external sort is couple of multifold. First, it is too much of engineering. Okay. And every time I'll have a different set of problem. Here, the problem was to find the frequencies. Here, first machine found the frequencies for you, machine 2 found the frequencies, and then we merged it. Okay, somehow we coded it and merged it. Similarly, these problems are going to come again and again for you. Okay, again and again these problems are going to occur. Here, machine 1's job was to find the frequency for you, machine 2's job was to find the frequencies, and then you did a merge on them. Okay, now you coded machine 1, you coded at machine 2, and then you did all of this. So this approach required a lot of work. Okay, it required a lot of work, and coordination is required, as Anto is saying. Okay, the other thing is that the other problems with the external sort is to defend against the things like one machine going down and checking it, and then if it is going down then we hand it over to somebody else. We needed another way of dealing with it. Or or since the data is anyway stored on those nodes, can we just send the code and let there be no data transfer? So that was the another deal. Here we had to send the data. If you could just tell that particular machine that read from this location to that location which is stored with you only, and so there would not be any network traffic. Okay, so there's a lot of engineering required, and trust me, when you are coding something like this, it requires a lot of hard work to get it right. Okay, just a sorting problem of finding the frequencies might become your 2 months job. Okay, it might become the 2 months job, and it will and still it may not be fail safe. So the solution which I am trying to come up is to convince you guys that hey, this is the reason people came up with MapReduce. They came up with the way that you don't have to code too much. All you have to describe your problem statement in terms of maps and reduces. Okay, in terms of maps and reduces, most of the underlying stuff like sorting and stuff is going to be handled by the framework, and you just need to describe your things in terms of maps and reduces. Now let's have a formal definition of maps and reduces. It's a programming paradigm that helps you solve big data problems. So Chintamani's question is, so sort of Unix is between map and reduce. Exactly, you got it right. Okay, so programming paradigm to help you solve big data problems. It's a programming paradigm to help you solve big data problems the way I just described, specifically sorting intensive jobs. Okay, I mean, if you have a graph related problem, you have to traverse your graph in which the sorting can only play a small role, then you need a different solution. Second, you just have to code two functions. One is mapper. Mapper's job is to convert your data into key and values, which underlying framework will sort by keys, and reducer will get all the values for the same keys aggregated together as an array. So you'll have to just write a function called mapper whose job is to convert any data into key values, and reducer whose job is to convert the key and array of values into a single value. So you can imagine that you will write these two functions and hand it over to the operating system, and operating system will first execute mapper on set of records. one by one, line by line. And then once you get the output of each mapper, the framework underlying takes this output, sort it by keys, and for each keys finds all the values and hand it over to your reducer. Okay. I'll keep on describing this phenomena again. Okay. And this is MapReduce is not specific nowadays to only Hadoop. MapReduce was again founded by, also patented by Google guys. Okay, they did it for their PageRank algorithm, and it's also supported by many other systems such as MongoDB, CouchDB. And mappers and reducers can be written. Mapper and reducer is your code, your piece of code, which define what is my ID and what is my value and what is my aggregate function. Okay. Can be written in Java, can be written in Shell, can be written in Python, or could be any simple binary which spits out key value pairs. Okay, okay. So Shashank is saying that, okay, I'll repeat uh, for Shashank once. So the job, basically, in case of whole map reduce paradigm, all you do is write a logic a function called map. You think of map as a command, okay, which takes as an input a whole text file. You convert it into key value pairs, howsoever you want to do. For each line, for each input record, your mapper is going to get called. Okay, and your mapper, based on what you are trying to achieve, you will write the logic in this. And reducer, the job of a reducer is to define an aggregate function. Either you use a standard one like average, sum, or something else, or you can do your own magics, because your reducer is your own command which you write, your own program. Howsoever you want to program it, you can program it. And the output of mapper is sorted by the framework and presented per key to reducer, which means for each key there might be multiple values, and those all values will be uh, presented as an array to reducer, and reducer will take it and then merge it together howsoever reducer wants to do it, and then return the merged values. And that is the role being played by the reducer. So your focus will always be how do you convert a tough problem into a sequence of mappers and reducers. Okay. Let's take more examples. Let's take more examples here. This will make it a little more clear. Mapper and reducer. Does shell means con shell bash? So shell here, where I'm using shell. Yeah, a shell is any binary, right? So any binary which you can execute from the command. Okay. So whether it's a slash bin ksh slash bin binary file. So any file which can be executed in Unix can be used as shell programming, as long as at the top you know that there's a shebang at the top of the file, right? Which starts with hash and then exclamation and then bin ksh bin sh, whatever you want to put, you put it there. Okay. So does it make sense to you? So any shell program, any file, you can use it in your using streaming jobs. We call them streaming jobs. Okay. There are total two mechanisms. One is using Java, another is using streaming jobs, in which any executable could be used for mapper and reducer, whether Python or anything, absolutely anything. Now let's have a look at this diagram again. Whatever I have just told, I'm writing it into this. So you understood that what is map. So you went ahead and you wrote for each word in the input line or input, print word comma I. So framework did one more thing for you. It converted your input file into line by line manner. And that for each line, your this function, map function is going to get executed. And your function has what it is doing. Let's call it, let's say emit or print. Let's just call it print. What it's doing is, and this is not specifically any particular programming language. I'm just written a pseudocode. So all it is doing for each word in the input, print word against one. So word space one, that is what we are printing here. Okay. In no particular manner. All we are trying to do is we read all the words from the input and we printed the frequency as one against each of these words. Okay. Now this thing, you see this dashed line. This is where Hadoop will play its magic and will convert this sorted list into this form. So it will first convert GA, GA, and then since 1 is only 1, so there is only one value here. Similar case is with RA, it is only once. But SA is twice here. So what it does is SA and against it will put these two values. Okay. Now it will be your reducer's duty, and this one, each of this one by one will be against each of these records, word against frequency array. This is frequency array. Your reduce function is going to called, and your reducer function will do something with the frequency array and return whatever it wants to do. Here in particular case, what we are doing is summing that array. Okay, and bingo, you got the frequency. Okay, out of from here till here. And now the important part of this whole magic is that it can handle up to how much of data you want to handle, meaning how much of data you can store in your network and how much of nodes you can have. You can handle that much of data. Okay, there is no limit to handling the data. Okay. So this is what happens. This is your mapper function. This is your reducer function. Mapper function took line by line. Out of that line, it picked up word. It printed word and one, word and one. That's it, word and one. Okay. And this word and one was taken by Hadoop and first sorted, then grouped. This is grouping. After it has grouped per key, after it has grouped per key, it handed over each of this id uh, key against values to your reducer function, or reducer function was called against each of these records. And in your reducer function you did some magic. Here you could write some average function or root mean square. This is up to you. This is your programming language. It might be Java, Python, JavaScript, or whatever, Node.js. Okay, whatever functionality your programming language provides to you, it will do. You can use those functions here. Yes. Okay. So similar way, here it's aggregation is array.sum. You could do root mean square value or some other things. If you are a data scientist or you're working onto the similar line, you will have lots of other values to do. Okay, you will do all sorts of things you want to do, mean, average, whatever, because it's a proper programming functional language. Whatever you're doing in, if you're using Python, you can properly use all the libraries of the Python. And if you're using Java, you can use all the function, everything from Java, or you can write your own logic. So this is completely yours. Unlike in case of databases, when you go for group by, for example, it becomes extremely difficult to code it there. Okay. Say you want to here, you want to convert this data into say ASCII code, and that is not provided by the database. Say when you say group by in your database, it becomes extremely difficult to cope up with that. Either you write your own functions provided by Oracle or something, right? Right. And that is why the, and this is flexibility of ability to code these portions, map and reduce, makes it possible, makes it a proper programming paradigm instead of a restricted library. So hope I'm able to explain to you this. And there is another diagram here. Okay, there is another diagram. Uh, So let's look at what is going on. There is first machine on which this went, this particular string went. This is first machine. Machine took it and converted into something like this. Okay. The step 2, this step 2 is depicted in this diagram here. Okay. This is what it got converted. Then sorting happened. Sorting happens like this. And once the sorting happened, the merge and shuffle happen. Okay. And once the shuffling happened, you get the result. Your reduce function was called against each one. So these three blocks, basically the portion, this dashed line is what it is. So for to complete, so under we can obviously guess what is going on. So under multiple machines, we asked we asked our name node or the launcher, we asked him ki, hey, this is my map definition. Here we defined our map definition, we defined our reduced definition and hand it over to that guy. What that guy did, I mean what that machine did, was to tell each of the nodes in the network that this is my mapper, this is my reducer, and this is the file which you already have this portion of the file. Run these mappers and reduce these maps. First it tells them to run the maps. Whatever output all of these guys have gathered after running the maps on those each chunk of the pieces here, whatever came as output here, all it did was it handed over it to sorting. Now sorting, after it has sorted the data, this is the portion which after which came out sorting it. This is sorting happening on each individual machines. Okay, after the sorting happen, the merge and shuffle will happen, and result of the merge and shuffle will further be split it again on multiple machines, and then the reducer will be executed on those machines. Okay, we'll cover this up again and again, but for now you can think of this as the magic. Your reduce and mapper will execute on multiple machine in the network. Okay, here you look at this slide again and you will get the idea. This is what is happening on machine 1, this is what is happening on machine 2, or node 1, node 2. Okay, so it's simply these two pieces of code did the job for you. Now there's another way to look at this job. Okay, okay, okay. Now, I mean, we can continue it later, but in the meantime, make sure you look at these assignments. I'm not asking, I'll continue from this slide tomorrow. Okay, this is an analogy you can take from the group by clause. When we say select word count star, So select word as well as group by, these two things are being done in the map function. Okay, while this count is being done at the map function. Okay, so this is the two things which we are doing. You can take this analogy when you think in terms of sorting and grouping. It will be easy to form your problem statement. Okay, in the meantime, what if you had to find the frequencies of the letters? Do you still need a map reduce? Okay, can you come up with a solution for frequencies of letters? Okay, frequencies of letters are pretty interesting part. Each language has its own frequencies of the letters, and using frequency of the letter you can actually predict which language it is. Okay, then second is finding anagrams. You have a huge text file. What map and reducers will you write to find the anagram? An anagram is basically a letters of a word rearranged. For example, take and act, take, cat, act. All three are this, right? All three are the anagrams of each other. Okay. Now, third one is little difficult problem. Third one is that you have got DNA sequences of all over the globe. Okay, and you have got user IDs of all the people in the world. You've got email IDs of all the people and their DNA sequences. You are looking for the people who have same DNA or a mirror of the DNA. For example, user 1, user 2, user 4 either have the same DNA or have the mirror image of each other. Okay, so you have to find out all such people and list them as this output. How will you do it? Using maps and reduces. Okay, so this is one problem statement. You have got files that contains DNA sequences. Now fourth problem which I'm going to pose is, this is little difficult. Think of an unusual democracy in which people are not equal to each other. People vote and their vote is counted in terms of their worth. So everybody has got some money in their bank account. Based on that, we count their votes. Somebody who is having more money, we say that his vote will be 5 times. Take this case. So we have got, first list is who voted for who. Second list is who is having how much worth. Okay. So A has got worth as 5, B has got worth as 1, and C has got worth as 11. And now A voted for C, B voted for C. Now the total worth of C becomes 6, while worth of F is 11. Now nobody voted for A and B. Their vote count is 0. How do you achieve this using maps and reduces? Because there are billions of people in the world for who this has to be done, and you cannot use your existing database systems to do it. Had it been database, it would be pretty simple to do. How would you do it? Using maps and reduces. All of these four problems I'm leaving it open ended so that tomorrow when we meet you have some time to think over these things. Okay, so this is pretty much for today. Feel free to drop me a message in case you get stuck somewhere, and I'll upload this today's session online, okay, which you can access from the KMS. Okay, so good night for today. Already we are running 15 minutes late. Okay, thank you, Chintamani. Yes, Hadoop is a perfect example of teamwork, like Germany at FIFA. Okay, Thank you, Shashank. I'm glad that you liked it. And Kalyan, thank you very much. Hope you liked it. Good night, guys. And let's meet tomorrow again. And, you know, yeah, thank you, Sukhsavat. And please work out these examples, go through these examples, because these are the assignments of the level of a data scientist. And probably because all of you guys are senior, you are looking forward to that kind of career. And I'm sure that I'll be able to convert most of the problems into MapReduce. Okay. Good night, guys. Looking forward to see you tomorrow again at the same time, 8:30. Good night to all. Good night, Shashank. Good night, Chintamani. Great. Hari, have you slept off? Are you there? Good night, Hari. And good night, Anto. I'm sure you must have liked the session and you'll continue to innovate in this domain. Good night, good noon to you. Okay, great, great, great. Okay, bye bye. Hari has slept off. Hari, are you there? Bye bye.